Hello students, welcome back to the eighth topic, that is interpolation and extrapolation. First we will see what is meant by interpolation. Interpolation is a procedure of estimating the unknown value of a dependent variable for a given value of independent variable which is within the limits or the range of the independent variable. It is a procedure of estimating the unknown value of dependent variable for a given value of independent variable which is within the limits or the range of the independent variable. Now we will see what is meant by extrapolation. Extrapolation is the procedure of estimating the unknown value of a dependent variable for a given value of independent variable which is outside the limits or the range of the independent variable. Now what are the assumptions of interpolation and extrapolation that we will see. The first assumption is there are no sudden jumps in the values of independent variable from one period to another. And one more assumption is that the rate of change of figures from one period to another, it should be uniform. So these are the two assumptions of interpolation and extrapolation. Then what are the methods of interpolation? There are two methods of interpolation, that is graphical method and algebraic method. Now according to the PUC first year syllabus, we are studying only the algebraic method of interpolation. Now we will see what is meant by algebraic method. A number of algebraic methods based on different assumptions have been developed for interpolation and extrapolation, and some of the commonly used methods are the binomial expansion method, then method of finite differences, and one more is Lagrange's method. But in the syllabus we have only the binomial expansion method. Now before going to study the binomial expansion method, first we will study or we will see what is meant by polynomial. The mathematical expression, that is a0 plus a1x plus a2x square plus a3x raised to 3 and so on, an x raised to n, is called polynomial of order n. Now we will see binomial method of expansion or binomial expansion method. As the name suggests, this method is based on the binomial expansion. This method is applicable under the following conditions or assumptions of binomial method. Here the arguments, that is nothing but independent variable, that is nothing but x values. The argument, that is x values, are equidistant, like 25, 30, 35, 40. Here you can observe the difference between two successive values is 5. That is all the values are equidistant from each other. Then that is the difference between any two successive values of x is a constant mathematically. The values of x should be in arithmetic progression. And one more assumption is there, the value of x for which the value of y is to be estimated must be one of the values of x. So these are the two methods or two conditions where we are going to apply the binomial expansion method. Now we will see binomial expansion method when it is used, or steps to use binomial expansion method, or how to use binomial expansion method. The first step is find the number of known values of y. X and y values will be given. How many y values are given, that we are going to count. Let us say in an example there are n known values of y. There are n known values of y. If n known values are there, then we have to take delta raised to n y0 equal to 0. This equation we have to take delta raised to n y0 equal to 0. Now we will see further what is meant by delta and all. Then expand the left hand side of the equation using binomial expansion. This left hand side, that is delta raised to n y0, that we have to expand by using binomial expansion. But take the exponents of y as the subscripts. Exponent of y we have to take as a subscripts. For example, take y minus 1 square as y2 plus 2y1 plus y0, which coincide with delta square y0. Now after this, the next step is substitute the given values in the equation. Whatever the values of y are given, those values we have to put in the equation. Then solve the equation for the unknown. Whatever the unknown value of y is there, for that we have to solve the equation. Now in the following table, the equations corresponding to few values of the n are given. Suppose there are two unknown values of y, that is n equal to 2. That is, equation is y minus 1 square. If we expand this, then you will get y2 minus 2y1 plus y0 equal to 0. If there are three unknown values, then n equal to 3, then equation is y3 minus 3y2 plus 3y1 minus y0 equal to 0. Similarly, suppose if there are 5 known values, then equation is y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y0 equal to 0. Or if there are n equal to 4 known values, then the equation is y4 minus 4y3 plus 6y2 minus 4y1 plus y0 equal to 0. We have to write the equations for given values of n, and the equations will be like this. Now we have the next step. The plus and minus signs are to be placed alternatively. We have to give the plus and minus sign alternatively. First we have to start with plus sign, then minus, then plus, then minus, like that. Then starting from the first, which will be plus, that is plus, then minus, plus, minus, and so on. Alternative sign will be there. Then numerical coefficients are found by referring the Pascal's triangle given below. Whatever the coefficients we are using here, or previous slide we will see. Here the coefficients we have used. For example, n equal to 4. We have used the coefficients here 1, 4, 6, 4, 1. Coefficients of y are 1, 4, 6, 4, 1 for n equal to 4. Now how to find these coefficients? That we have to find by using this Pascal's triangle. Here you can observe n equal to 4 and the coefficients are 1, 4, 6, 4, 1. By using these coefficients, we are going to write the binomial equation for given values of y, or known values of y. And this Pascal's triangle is nothing but binomial coefficients. In the statistical tables, you will have binomial coefficients. Binomial coefficients is nothing but your Pascal's triangle. By using that binomial coefficients, we can write the binomial equation for any known values of y, that is dependent variable. Now we will solve one example. The example is the following table. In the following table, the values of x represents the degrees of freedom and the y values represent the chi-square values at 5% level of significance. Find the missing value. Now whatever may be it is a chi-square distribution or degrees of freedom, doesn't matter. Here x and y values are given. X values are 2, 3, 4, 5, 6, 7. And y values are given 5.99, 7.82, 9.49, 11. Here for x equal to 6, y value is missing, and one more value is given of y, that is 14.07. Now you can observe the difference between two successive values of x is common. Okay, that is the first condition to use binomial expansion method. And one more is the values of y should be missing corresponding to values of x. Here you can observe one value of y corresponding to value of x 6 is missing. So we can use binomial expansion method. Now given data, we'll write the notations. X values will write as it is, y values will write as it is, and here we are going to denote x and y values as first value of x as x0, then x1, x2, x3, x4 and x5. Similarly, y values, first y value as y0, y1, y2, y3. Here y4 value is missing, but we will write the notation y4, and last value is y5. Then the values of x increases by 1 and the unknown term is y4, which corresponding to x4, that I already told in the last slide. Here we are using binomial expansion method. Now you can observe how many known values of y are there. You can observe 1, 2, 3, 4 and 5. Here 5 known values of y. That only we are writing here. Here 5 known values, and so we are using the equation as y minus 1 raised to 5 equal to 0. This leads to the equation by using binomial expansion, binomial coefficients, and n equal to 5. We can expand this left hand side of this equation y minus 1 raised to 5 as like this. We have seen how to write the equation in one of the last slide. We can write y5 minus 5y4 plus 10y3 minus 10y2 plus 5y1 minus y0 equal to 0. Here you can observe signs we have used here, starting with plus. Here plus, then minus, plus, minus, plus, minus. Then n equal to 5 is there. So subscript we are using as, first we are going to start by 5 and then we are going to reduce by 1. You can observe here subscript, here 5, then 4, 3, 2, 1 and 0, up to 0 we are going to write. Then coefficients for n equal to 5, you can observe the binomial coefficients or Pascal triangle. You will get the coefficients of this y term. You can observe for n equal to 5, you have the coefficients 1, 5, 10, 10, 5 and 1. By using all this, we can write the equation for n equal to 5 like this, that is y5 minus 5y4 plus 10y3 plus minus 10y2 plus 5y1 minus y0 equal to 0. Now in this equation we are going to put the given values of y, whatever y values are given from last table or last slide, those values we will put and simplify further for y4, because y4 is missing, it is not given, that we have to find. After simplification you will get 5y4 equal to 62.28, and finally if you divide 62.28 by 5, then you will get y4 is equal to 12.456. that is the missing observation for x equal to 6, that is y4 equal to 12.456. Now let's see one more example. Use the binomial expansion method to ascertain the most likely index number for the year 1983, and here the data is given, year and index number. Year is 1981, 1982, 83, 84 and 85, and corresponding index numbers are 100, 107. Here for 1983 is missing, then 157 and 212. Now like last example, we are going to denote x and y values. Okay, x values we are going to write, y values we are going to write, and we are going to denote by x0, x1, x2, x3, x4, and here y0, y1, y2, y3 and y4. Here y2, that is y value for 1983 is missing, and that we have to find. Now we will count the known values of y. Here 1, 2, 3 and 4. 4 known values of y. 4 known values. So we can write the equation, or we can use binomial expansion like this, y minus 1 raised to 4 equal to 0. Since n equal to 4 or known values are 4, we can use the power of y minus 1 as 4. Now we can expand this equation and we can get this equation, that is for n equal to 4 we have the coefficients from binomial expansion, binomial coefficients or Pascal's triangle, that 1 4 6 4 1. By using that we can write the equation, that is y4 minus 4y3 plus 6y2 minus 4y1 plus y0 equal to 0. And then we are going to put the known values of y in this equation, and you will get 212 minus 4 into 157 plus 6y2 as it is, because we have to estimate y2, minus 4y2 into 107 plus 100 equal to 0. Then after simplification you will get 6y2 is equal to 744. Then if we divide 744 by 6, then you will get y2 equal to 124. Hence the probable value of index number for the year 1983 is 124. So these are the examples on binomial expansion method, that is for interpolation and extrapolation. Now here some examples are there, you can try it at home. Interpolate the missing figure, and here year and sales in 1000 rupees are given. Year are given 2001, 2, 3, 4, 5, 6, 7, and sales in 1000 rupees are given 100, 120, 150, 180, 210. For 2006 is missing, and last is 320. You can simplify by using binomial expansion method. Here 1, 2, 3, 4, 5 and 6 known values. So we have to write the equation for n equal to 6 by using binomial coefficients. And for n equal to 6, binomial coefficients are 1, 6, 15, 20, 15, 6 and 1. By using that we can write the equation for n equal to 6. And then put the known values of y and simplify for 2006. One more question is there. Interpolate the index number for 2008 from the following data, and here year and index number are given. Year 2006, 7, 8, 9, 10, and index numbers are given 278, 281. For 2008 it is missing, then 313 and 322. Here you can count the known values of y, that is 1, 2, 3 and 4. So 4 known values. So we have to write the equation for n equal to 4 by using binomial coefficients. And for n equal to 4, binomial coefficients are 1, 4, 6, 4 and 1. Then one more question is there. From the following data, interpolate the production of cement in 2007. Here year and production is given. Just I will tell you how many known values. 1, 2, 3, 4 and 5 known values. So for n equal to 5 you can write the equation, and for n equal to 5 you have the coefficients, that is 1, 5, 10, 10, 5, 1. By using those coefficients we can write the equation, that is delta raised to 5 equal to 0, that is y minus 1 raised to 5 equal to 0. Then last one more question is there. Use binomial expansion method to estimate the index number for 2005. And here 1, 2, 3 and 4 known values are given. Means you are using binomial coefficients as 1, 4, 6, 4, 1. By using those coefficients we can write the equation, then put the given values of y and simplify for 2005. You will get the index number for 2005. So these are the examples on interpolation and extrapolation. This is also very small topic, and in PUC second year same topic we are going to study, but in PUC first year you can observe here we have used for single missing observation. Only one missing observation is there in the data, but in PUC second year there will be two missing observations in the series. One observation will be within the series, one observation will be outside the series, like this. And we are using binomial expansion method also, and one more method we are going to study for PUC second year, not for first year, that is Newton's advancing difference method. So with this we have completed your one more topic, that is interpolation and extrapolation. So according to the reduced syllabus for 2020-21, your syllabus for PUC first year statistics is completed. 2 units were reduced, that is theory of probability and random variable. Those 2 units you can go through the textbook which is prescribed by PU board, and from that whatever your doubts, queries, questions will be there. Whenever the offline classes will start, at that time you can ask your queries from that also. So today we are going to complete your syllabus for PUC first year. Now afterwards still online classes will be going on, but we will start from the beginning. Thank you.